Hello everyone. Welcome back to Introduction to Artificial Intelligence and Machine Learning. In the previous session, we give an overview and introduction on the general machine learning workflow. In this session, we will focus on major types of machine learning algorithms and their corresponding use cases. As we learned in the previous session, machine learning is a common sense, but for a computer. It mimics the process in which human makes decisions based on experiences by making decisions based on previous data. Of course, this is challenging for computers, as all they do is store numbers and do operations on them. So programming them to mimic human level of thought is difficult. Machine learning is divided into several branches, and they all mimic different types of ways in which humans make decisions. In this session, we overview some of the most important of these branches. Machine learning has applications in many fields, such as predicting house price, predicting stock markets, detecting spam email, facial recognition, self-driving car that is able to navigate, or playing games like chess. Try to imagine how we could use machine learning in each of these fields. Some applications look similar. For example, we can imagine that predicting housing price and predicting stock price must use similar techniques. Likewise, predicting if an email is spam and predicting if credit card transactions are legal or fraudulent may also use similar techniques. What about teaching a vehicle to drive itself? That sounds very different than predicting housing prices, but it sounds similar to teach a machine to play chess. Machine learning models are grouped into different types according to the way they operate. The main three families of machine learning models are supervised learning, unsupervised learning, and reinforcement learning. In this session, we will mainly focus on supervised learning and unsupervised learning, as they are the most natural ones to start with, and arguably the most commonly used. Supervised learning and unsupervised learning are the major techniques of machine learning. But both the techniques are used in different scenarios and with different datasets. Below, the explanation of both learning methods along with their difference table is given. Supervised learning is a machine learning method in which models are trained using labeled data. In supervised learning, models need to find a mapping function to map the input variable x with the output variable y. Supervised learning needs supervision to train the model, which is similar to as a student learns things in the presence of a teacher. Supervised learning can be used for two types of problems: classification and regression. Unsupervised learning is another machine learning method in which patterns infer from the unlabeled input data. The goal of unsupervised learning is to find the structures and patterns from the input data. Unsupervised learning doesn't need any supervision. Instead, it finds patterns from the data by its own. Unsupervised learning can be used for two types of problems: clustering and association. As mentioned above, the clear difference between supervised learning and unsupervised learning is that one is using labeled data, another one is using unlabeled data. Actually, what is data? Let's first establish a clear definition of what we mean by data. Data is simply information Anytime we have a table with information, we have data. Let's say, for example, that we have a data set of pets. The pet images are our data. So how about label? This one is a bit less obvious, and it depends on the context of the problem we are trying to solve. Normally, if we are trying to predict something based on the others, that is the label. If we are trying to predict the type of pets we have, for example, a cat or a dog, based on information on that pet, then this is the label. Clearly, it is better to have labeled data than unlabeled data. With a labeled data set, we can do much more. But there are still many things that we can do with an unlabeled data set. Let me give you a concrete examples of supervised and unsupervised learning. Suppose we have images of different types of pets. The task of our supervised learning model is to identify the animals and classify them accordingly. So, to identify the images in supervised learning, we will give the input images as well as the labels for that, which means we will train the machine learning model with the images and labels. Once the training is completed, we will test the model by giving the new set of animals. The model will then identify the animal and predict the output using a suitable algorithm. Unlike supervised learning, in the case of unsupervised learning, we will not provide any supervision to the model. That means no label is provided. We will just provide the input images to the model and allow the model to find the patterns from the data. With the help of a suitable algorithm, the model will train itself and divide the animals into different groups according to the most similar features between them, such as similar colors or similar shape. And then, a domain expert is required in order to give a label to the cluster images datasets. Let's take a look at some use cases for supervised learning. Supervised learning has been widely adopted in finance industry because banks and other financial institutions collect lots of data about their customer transactions. Trading houses also heavily relies on real-time market information. So, one use case for supervised learning is in financial trading. Because many people are eager to be able to predict what the stock market will do on any given day, for obvious reasons. But here, machine learning algorithms are getting closer all the time. Many prestigious trading firms using proprietary systems to predict and execute trades at high speeds and high volume. Another use case for supervised learning is in the domain of marketing and sales. Nowadays, digital marketing and online-driven sales are the first application fields that you may think of for machine learning adoption. People interact with the web and leave a detailed footprint. That is a lot of data to be analyzed. For example, you can analyze customer churn. A customer who churns is the one who ceases to complete target actions, such as adding the product to a shopping cart, leave a comment, or check out with their credit card during a given period. So we can use machine learning to predict customer churn. Second is response. We want to do target advertisement or marketing campaign to customers who are likely to respond to our campaign than to those who would treat it as spam. So we can use supervised learning to predict customer response so that we can have a better targeting rates. How about use case for unsupervised learning? Here I will give you some. First, and most importantly, is customer segmentation in the marketing field. This is use unsupervised learning to understand different customer groups around which to build marketing or other business strategies. Secondly, genetics analysis. For example, we can use unsupervised learning to cluster DNA patterns to analyze evolutionary biologies. We can also use unsupervised learning to build a recommender system, which involve grouping together users with similar viewing patterns in order to recommend them similar content. Lastly, anomaly detection. This includes fraud detection or detecting defective mechanical parts. We can use it in predictive maintenance in manufacturing production lines. Finally, let's take a look. This table shows the key difference between supervised learning and unsupervised learning. Firstly, supervised learning algorithms are trained using labeled data, while unsupervised learning algorithms are trained using unlabeled data. For supervised learning model, it predicts the output, and unsupervised learning model finds the hidden pattern instead. And in supervised learning, input data is provided to the model together with the output, while there is no output provided for unsupervised learning. And supervised learning can be used for those cases where we know the input as well as corresponding data, while unsupervised do not have corresponding output data. And supervised learning model can produce an accurate result because we can evaluate the model using the output data. But for unsupervised learning model, it may give less accurate results as compared to supervised learning. Finally, supervised learning is not close to true artificial intelligence, as in we first train the model for each data, and then only it can predict the correct outputs. But unsupervised learning is more like true artificial intelligence, as it learns similar as a child learns daily routine things by his own experiences. Please note that both supervised and unsupervised learning models are machine learning methodologies, and selection of any of these learning depends on the factors related to the structure and volume of your datasets and the use cases of the problem.